Hello. In continuation with the case study based questions, here is a question which was tested in 2026. At a birthday party, the children are being served orange juice in a conical cup as shown in the figure. The dimensions of the cup are 15 centimeters height and 5 centimeters radius. Each cup is 15 centimeters and radius 5 centimeters. Juice is poured into this cup at the rate of 0.1 centimeter cube per second. That means dV by dt is 0.1 centimeter cube per second. On the basis of the above information, answer the following questions. Find the relation between the height h of the juice in the cup and the radius r of the surface of the juice in the cup if the semi-vertical angle is alpha. So that means they want a relation between r and h. So they want a relation between r and h. So we can see that from the triangle, we can see from the big right triangle, this is the right triangle, this is another small right triangle. We can understand that tan alpha is equal to opposite side divided by adjacent side, 5 divided by 15, which is equal to 1 by 3. From the small right triangle, we can understand tan alpha is equal to r divided by h. So we get a relation r by h is equal to 1 by 3, or we can say h is equal to 3r. So when we take the r is the radius of the juice present in the cup and h is the height to which the juice is present, the relation between this h and r is always h is equal to 3r. The second part of the question is, at what rate is the juice level in the cup rising when the juice is 6 centimeters deep? That means they are asking what is dH by dt. But we are given dV by dt is equal to 0.1 centimeter cube per second. We are given dV by dt is equal to 0.1 centimeter cube per second. We are asked to find out what is dH by dt. So we'll take the formula for the volume. Volume of the cone is equal to 1 by 3 pi r square h. We are interested in dH by dt. We know dV by dt. So I will replace r as h by 3. So you get 1 by 3 pi h by 3 the whole square into h. This gives us pi by 27 times h cube. Now let's differentiate on both the sides. dV by dt is equal to pi by 27 3h square into dH by dt. We are given dV by dt is equal to 0.1 centimeter cube per second. Pi by 27 into, we are given an instantaneous height when the juice is 6 centimeters deep. So h is equal to 6 square into dH by dt. I think some cancellation is possible. uh, uh, 6 can be written as 3 into 2 into 3 into 2. 27 can be cancelled. So we are left with 0.1 is equal to pi into 4 into dH by dt. That gives us dH by dt is going to be 0.1 divided by 4 pi, or it is 1 by 40 pi centimeter per second. So the rate at which the juice level is increasing at an instant when the juice is 6 centimeters deep. Then the third subdivision is, when the juice is 6 centimeters deep, find the rate at which the upper surface of the juice is increasing. So what is the h is equal to 6 centimeters. They are asking what is the area of the juice, the rate at which the upper surface area. The upper surface of the cone is going to be the surface of the cone. The upper surface of the cone is a circle. So area of a circle is going to be pi r square. They are asking us to find out dA by dt. But we know only dH by dt as 1 by 40 pi. And we also know r is equal to h by 3. So let us replace this r as h by 3. So we get a h square by 9. So dA by dt is what is wanted. That is pi by 9 into 2h into dH by dt. We are asked to find out at an instance when the depth is equal to 6 centimeters. So this is going to be 2 into 6 into dH by dt. We have evaluated it as 1 by 40 pi. 1 by 40 pi centimeters per second. So I think some cancellation is possible. 2 20s are, 2 3s are, 2 10s are, 3 3s are. So I am just getting this to be, and pi can be cancelled. So I am just left with 1 by 30 centimeter square per second is the rate at which the area of the juice, the rate at which the upper surface of the area of the juice is increasing. The choice question is, when the juice is 6 centimeters deep, find the rate at which the wet surface area. So subdivision 3b. So H is equal to 6 centimeters. What is the wet surface area? The wet surface area is nothing but the curved surface area of the cone. So we are asked to find out ds by dt, where s is equal to pi r l. So let us replace this L as root of r square plus h square, and we know only dh by dt. We know dh by dt. So, and we are interested in ds by dt. So let us replace r in terms of h. The relation between r and h is r is equal to h by 3. So replace r as h by 3, and this is going to be h square by 9 plus h square. This is going to be pi by 3h into 10h square by 9. Inside the root we have a 10h square by 9. So root 10h divided by 3. So surface area is going to be root 10 into pi divided by 9 into h square. Now let us differentiate. So rate at which the wet surface area is increasing is ds by dt. That is root 10 into pi divided by 9 into 2h into dh by dt. 2h into dh by dt. So it is root 10 into pi divided by 9. H is 6 centimeters. So 2h is 2 into 6, and dh by dt is 1 over 40 pi. Let us see what can be cancelled. A pi can be cancelled. 3 3s are, 3 2s are, 4 10s are. So I am left with a root 10 on top and a 30 in the denominator. So I can cancel a root 10 and a 10. So we get 1 by 3 root 10. 1 by 3 root 10 centimeter square per second is the rate at which the wet surface area of the cone is increasing. When the juice is 6 centimeters deep, find the rate at which the wetted surface area of the cup is increasing. The wet surface area is nothing but the csa of the cone. Csa is equal to pi rl. Replace L as root of r square plus h square. Because we have what is dh by dt we have already got, we can find replace r as h by 3 and then differentiate on both the sides with respect to t. Replace dh by dt as 1 by 40 pi and h as 6 centimeters. We get the rate at which the wet surface area of the cone is increasing.